Okay, very good afternoon to all. In the previous session, already we have started the unit 1, right? And out of that, so we have completed the what is data structure, types of data structure, static, dynamic, primitive, non-primitive, linear, non-linear. And after that, next searching algorithm. So both searching algorithms, so we have discussed. Is it completed? Linear search and binary search. Hello. I think
yes, sir.
Yeah, linear search and binary search, both the theoretical part I have explained and the program of linear search I have explained. So binary search is also, I think you are able to complete that program, and I have given you the task at the time of practical. So most of you have completed the programming part. So I think no need to go through that programming part, right? So now today we will finish this last point. So that is study and implementation of sorting algorithms. Or bubble sort, insertion sort, merge sort, quick sort, selection sort, shape sort, radius sort, and heap sort, right? Now, yesterday I have given the task that is the implementation of bubble sort, right? So I think except few of the students, all of you have completed the implementation of a bubble sort. It means that you know the concept. So all of you are aware with the concept of sorting algorithms? For what purpose you are using the sorting algorithm? Hello. Is it visible to all, this PDF?
Yes, sir.
Yes, sir.
Okay. So data structure sorting algorithms. Now, so today we will go a little bit fast. So because you know the concept, so that's why. So this is a revision part for you, right? But we'll not skip this part. We'll discuss the theoretical points, and at the time of practical, we'll go for the implementations, right? So what do you mean by sorting? Or what is the purpose of use of sorting? Or is it required compulsory in a data structure? Or what will happen if we not use the sorting algorithm? Or where it is useful? So can anyone? Yes. Hello. Definition of sorting, or what is mean by sorting? Sorting means काय exactly?
Finding the elements.
Finding the searching. I'm not asking about searching. I'm asking about sorting.
Arranging the data in particular manner.
Okay, good. Arranging the data in a particular manner, or arranging the data in incrementing or decrementing orders, right? Now this PDF is visible to all. So is it visible properly on a screen?
Yes, sir.
Yes, sir.
Yeah. Now sorting. So actually we are using for the arrangement purpose, or suppose there is some particular format is given to you, or a random number is given to you. Now to arrange these random numbers, so we need to go for the sorting algorithm. We need to go through the sorting algorithms, right? So previously we discussed the two algorithms, linear search and binary search. Now for the binary search, so whatever the data you are providing, so that data is required in a sorting orders, right? In case, suppose you want to apply the binary search algorithm, and the whatever the data you got, so that data is not in a ordered manner. So for that purpose, first you need to arrange them into the ordered manners, and after that you are able to apply the binary search. So to arrange them in a particular format, or to arrange them in a particular sequence, so first we need to apply the sorting algorithms on unsorted order list, and after that you are able to apply the binary search algorithm. Right, binary search algorithm always we are applying on a sorted list. Right, now the importance of the sorting. So what is where it is applicable, or what are the applications? So here the two examples is given. So one everyone is using, that is the telephone directory, and after that another one is the dictionary. So nowadays everyone is using the mobile phones, right? Now in your mobile phone, so there is a one application, so that is the contact list, right? So in that, so whatever the number you are storing, so that is stored randomly or as per your storage sequence. So how the number you are storing in your mobile?
So sequentially.
Sequence it is. Some particular format is followed by that contact, right? So that contact application, right, or that contact feature, we'll say it is a feature of that mobile, right? So one of the feature, so that is a contact list. So in that we are saving the first name, last name, to that mobile numbers, workplace mobile numbers, again email ID, so many things you are able to store by considering a, if you store the information or if you save any number, right? Now in that, so again one more option is there in your setting, right? So how you want to sort the number, right? So by using first name, or by using last name, or by using the middle name, like I think so many options are there for sorting purpose. Or how to view the contact list. Is there any option is there in your mobile in contact for the viewing purpose? Option आहे का काही contact मध्ये? Yes or no? Just to go through the contact. Here you can see. I think all of you are having the mobile, so just you check. So how many options are there in a contact for sorting purpose? Is there any option or not? How to show the numbers? What is the option in your contact? काय option आहे?
Sorted by first name.
Sorted by first name, right?
Given name, family name.
Given name, family, right? So I think everyone is aware with this. So what we are doing, so we are using the, sometimes we are using first name, right? And that first name, so alphabetical sequence is considered. In that case, alphabetical A to Z sequence is considered. If your name is starting from A, so here you can see. So in the participant, is it visible to all participant list? So I have opened here. Is this a participant list?
No, sir.
Okay, just you can check the participant list also. So this list is also in a sorted order, right? So you are joining at a different time, but the list here I'm getting, that is in a sorted order. Suppose C_01. So it's first, after that 2, after that 3, 4, 5, 6 is absent, 7, 8, 9, after that 10. So 5 is at the bottom. So yeah, directly 5 written. So if Divya, so if you write a 05, so it will come after 04, right? So you have written directly 5, that's why it is coming later, right? After 50. So here first digit, after that second digit, and after that third digit is considered in case of a string sorting, right? But here generally we are using the numbers for the sorting purpose, right? So number everyone knows. So by using incrementing order or by using the decrementing order, we are able to search, right? Now another application is dictionary. The dictionary stores the word in alphabetical order so that searching of any word becomes easy. Right. Now, suppose if you want to search any word, so what you are searching or how you are searching, so you are considering the first letter, after that second letter, after that third letter, and generally by considering first 3-4 letters, so you will get that words, right? So these are the real-time applications we are using related to the sorting algorithms, right? So in place of, so again, the sorting is considered as a in-place sorting and not in-place sorting. So what is meant by in-place sorting and what is meant by non-in-place sorting? Suppose if you are performing any sorting algorithms, right? And if you require some extra space for the sorting purpose, so these kind of algorithm is coming under the not in place sorting. And the algorithm or whatever the array you are using, so they are using their own pace and sorting the list, right? So these kind of algorithm is called as a in place sorting. In place sorting म्हणजे काय की जे लिस्ट किंवा जे काय order of format असेल, suppose they are utilizing their own memory, whatever the memory is allocated for them, right? So for storing purpose, so by utilizing the existing memory, if the particular element is sorted, so by utilizing the existing memory, so these kind of sorting is coming under the in place sorting. And if it requires the extra pace, right? Or suppose program requires some extra pace to sort the algorithm or to sort the list, so these kind of sorting is coming under the not in place sorting. So here the definition is given. Sorting algorithm may require some extra space for comparison purpose and temporary storage of few data element, right? So these algorithms do not require any extra space, and sorting is said to happen in place. So for example, within the array itself, so this is called as an in place sorting. So here the best example of the in place sorting is the bubble sort. And in some sorting algorithm, the program requires the space which is more than or equal to the elements being sorted, right? So sorting which uses equal or more space is called as a not in place sorting. So merge sort is an example of the not in place sort, right? In the merge sort, we are using the divide and conquer approach, right? So for your information purpose, so this is not a part of your syllabus, so only for your information, you know the what is meant by in place sorting and what is meant by non in place. Now what is meant by stable and non-stable? To whom you are calling stable and non-stable sorting? Stable, non-stable. So these diagrams are visible to all. Is it visible? Now sometimes,
Yes, sir.
yeah, sometimes, so if you are considering the list of numbers, right? You are considering the list of numbers. So can we consider the duplicate numbers in a list? अशी possibility असू शकते का? Duplicate number असू शकतात का?
Yes, sir.
Yes. Now you can observe this the given list here, right? So here, how many elements are there? किती elements आहेत तिथे?
10.
10 elements are there. So in that, so which element is duplicate element here? (26), right? Is it visible, Don? Is it visible?
Yes, sir. Yes,
This
sir.
list, 26 is a duplicate element, right? Now, 26 is a duplicate. It means that, so when you are sorting, so which 26 you are considering first? Which is present at the index 6 or which is present at index 8?
6, sir.
Index 6, sir.
Index, sir.
index 6 you need to consider first, and after that you are considering the index 8 number 26, right? So if you are considering the duplicate element as per their sequence, so then these kind of sorting is called as a stable sorting, right? Now here the definition is given. So if a sorting algorithm, so after sorting the content, does not change the sequence of similar content, does not change the sequence of similar content which in which they appears. So these kind of list or this kind of sorting is called as a stable sorting. Right. Now we'll consider the same example. Right. Same example here. Now here the 26 which is present at the 6th index, I have denoted by using a light blue, right? And here light pink color I have used, or light pink will say 26. So the 26 which is present at the 8th location and 6th location, 6th index, right? Index. Now at the time of sorting, so which 26 I have considered first? 8 number index is 26 I have considered, or 6 number index. Now you can differentiate by considering their colors. The colors बघून तुम्ही differentiate करू शकता. This 26 is present in at which index in the unsorted order list? Unsorted at 8th location, right? And here at the 6th location. Have you followed the sequence of similar content here? Sequence follow केलाय?
No, sir.
There will not be any impact in a sorting. Sorting correct आहे. The sorting is correct, but here is the sequence is followed.
No, sir. No, sir.
Yeah. So these kind of sorting is called as an unstable sorting. यालाच आपण काय म्हणतो? Unstable sorting. Right. So here in if a sorting algorithm after sorting the content changes the sequence of similar content in which they appear, it is called as an unstable sorting. Right. Now stability of an algorithm matters. So when we wish to maintain the sequence of original element, like in a tuple, for example. So tuple, so have you heard the word tuple? Tuple word I click?
Yes, sir.
Yeah. What you are using in the tuple? Tuple मध्ये काय use करता? I think you have heard this word in Python. Python मध्ये ऐकलंय का? Tuples.
Yes, sir.
काय असते tuple म्हणजे काय असतं? Combination of what? Index and value. Tuple म्हणजे काय? Combination of index and value you are storing, right? So in case of tuple, so this will matter, right? So stable sorting and unstable sorting. If you consider the sorting for tuples, or if you consider the sorting for any string, so at that time, so this stability concept is now in case of numbers, so there will not be any impact of this stable and unstable, right? Now all of you understood the concept of what we discussed: in place sorting, not in place, and after that we discussed stable and non-stable, right? So these are the basic concept you are using when you are going for the real-time applications. So you need to follow these concepts. Now after that, adaptive and non-adaptive sorting algorithms. So sorting algorithm is said to be adaptive, right? If it takes the advantage of already sorted elements in the list, so that is to be sorted. So while sorting, so if the source list has some of the elements are already sorted, an adaptive algorithm will take this into the account and will try not to reorder them, right? So in case, suppose you have 10 or 100 elements are there. Out of that, So 50 to 60 elements are already in a sorted order. Already they are in a sorted order at that time. So those elements are not in a sorted order. So only sorting is applied on that. Right. So this kind of algorithm is called as a adaptive sorting algorithms, and non-adaptive means so we are applying the sorting throughout the list. So this is called as a non-adaptive sorting. So these are the few terms. So just for your kind information, so we are discussing here. Now important terms. So increasing order, decreasing order, non-increasing order, non-decreasing order. So I think everyone is aware with the same. Now, we'll start from the first sorting algorithm. So bubble sort. Right. So this is the very, very simplest sorting algorithms. And here, what type of approach you are using for the sorting purpose in the bubble sort? How you are applying the sorting? Hello. I think yesterday, I think all of you have completed the implementation of the bubble sort, and today we are discussing the same concept. It is a comparison-based algorithm.
Yes, sir. Yes, sir.
So adjacent element is compared with each others. Is it right?
Yes, sir.
Yes, sir.
Yes, sir.
One number is compared with the other.
Yes, yes. Very good. Very nice. Good, good, good. Go ahead. Yeah, I think your voice is not good.
So in bubble sort, from first index, that is the 0th index, to the end of the array index,
Mhm.
each number with another number it's compared. If it's greater, depends upon how we sort. Wants to sort
Ascending order.
ascending
will
or
best.
descending, depends upon greater things and smaller things.
Hmm.
One number is compared with the another number, and when it's matches or does not match, if it matches, then kept like that, and if does not match, it is shuffled with each other, and at the
Swapping,
end of the
swapping. Yeah.
digit, and at the end of the array, we get the particular array in whatever type we want. That's
Yeah.
simple. That's it.
Yeah, sure. Now we'll take example of one list as an example, and after that we'll discuss how bubble sort works. So we take an unordered array, so as an example, and we'll apply the bubble sort on that unsorted array. So here the list element of that array is 14, 33, 27, 35, and 10. Now apply the bubble sort on that list, right? So first you need to check. So bubble sort start with the very first two elements, right? So comparing them to check which one is greater, right? So as you said, so which elements are there? First is the 14, and second one is the 33. Now compare these two elements. Now in this case, the value 33 is greater than the 14, and so it is already in a sorted location. So next, what you need to do? इथलीच लाईट बंद झाली बाहेरनं बंद केलं स्विच बंद केलं now bubble sort. Now here the first two elements we have compared, right, and already they are in a sorted order. Now next iteration, so sorry, this is the first iteration, right? Now next step in the first iteration, so you are comparing the second element with third or third element with fourth. Now
Second element with third, sir.
yeah, good. Now in case the already here the 33 is greater than the 14, so we'll keep them as it is, right? Now 33 is compared with 27. 33 is compared with 27. Now 27 is less or 33 is greater than the 27. We need to apply the swapping, right? So we find that 27 is similar than 33 and these two value must be swapped. So everyone is aware with the swapping concept. So how you are doing the swapping? Swapping kasa karta? Logic of swapping. Suppose we'll store first value in variable A, second value in variable B, and again, is there any third variable we need to take for the swapping? Yeah.
Temporary variable.
Yeah, one temporary variable. Yeah, we'll say temp, right? Temp, right? So first, what you are doing? So temp is equal to A, right? And after that, A is equal to B, and B is equal to temp you are writing, right? So these three steps you are using for swapping purpose. Now here we'll swap the element 27 and 33. After swapping, the new array should be look like this. Right now, next we compare the 33 and 35. So we are repeating the same steps up to what? So here, this is the first iteration. So in the first iteration, so last element is at their place. So greatest element is stored at the end of the linked list. Sorry, end of the list, not end of the list. So 35. Now, for every iteration, how many elements are sorted in one iteration? एका iteration मध्ये किती elements sort होत आहेत? Generally, or worst case, in one iteration, how many elements are sorted? Let it be, so list is not in
Two elements.
Yeah, 2 element एका iteration मध्ये. आता इथं 35 sorted झालेलं आहे in the first iteration, but 33, 10, so still they are not in sorted order. एक iteration, one iteration means what? What is mean by iteration? Iteration म्हणजे काय?
Sir, in one iteration, two numbers are compared and only one number is sorted according to its greatness.
Now we have sorted this 35, right? So here last swap is 10 and 35. आता इथे एक iteration complete झालं की steps complete. These are the steps. So which are following for the first iteration. पहिल्या इटरेशन मध्ये आपण हे स्वॅपिंग ह्या स्टेप्स आहेत त्याच्या कम्पेअर करण्याच्या आणि हे इथं फर्स्ट इटरेशन कंप्लीट झालेलं आहे तुमचं आणि इन द फर्स्ट इटरेशन यू हॅव सॉर्टेड द वन एलिमेंट विच इज द ग्रेटर राईट नाउ बाय कंपेअरिंग नाउ अगेन वी आर स्टार्टिंग टू बी प्रिसाइज सो वी नाउ शोइंग हाउ an array should look like for after each iteration. So after second iteration, now again we are starting next iteration. Next iteration कसं start करणार? Again we are comparing 14 and 27. Right? After that 27, 33. After that 33 and 10. So 33 will come here and 10 will be at this side. Swapping. So after completion of next iteration, so you will get a two sorted array. Right now, after completion of third iteration, you will get a 3 elements. Now, after completion of fourth iteration, so you will get this 4, and automatically the first element is get sorted. Means how many iterations you require to sort the single array? If you are having how many elements? 5 elements are there in your list. So how many minimum iteration you require to sort out the element or maximum iteration? How many maximum iteration you require to sort the array? If you are having 5 elements, 5 एलिमेंट्स असतील तर किती इटरेशन्स लागतील तुम्हाला? इटरेशन म्हणजे काय? सो यू आर कंपेअरिंग द नेबरिंग एलिमेंट. दीज आर द स्टेप्स, राईट? सो यू आर फॉलोइंग इन वन इटरेशन. हे एक इटरेशन झालं, 35 शॉर्ट झाला म्हणजे हे पहिलं सगळं हे फर्स्ट इटरेशन झालं, राईट? सो दिस इज द फर्स्ट इटरेशन, राईट? So for the first iteration, we need to follow the maximum steps. Now for the second iteration also, we have followed the same steps. Now after second iteration, so you will get the array like this, sorted array. Now after third iteration, you will get this. And after fourth iteration, you will get the array like this. नाही येत light.
लाईट बघा
बंद झालं.
बंद करा. चार्जिंग लॅपटॉप चालतोय.
तिकडनं असं बंद बघ.
कुठं काहीच करणार.
Now all of you understood how many iteration. Now here how many elements are there? 5 element is there. Now how many iterations you required here? Then iteration किती लागतील? जर 5 नंबर्स असतील तर इटरेशन किती लागतील? मॅक्सिमम इटरेशन टू सॉर्ट द array by using the bubble sort. Hello, am I audible to all? आवाज येतोय ना? हॅलो, हॅलो, आवाज येत नाही का? हॅलो, hello, roll number 1, am I audible? Hello,
Yes, sir.
yeah. So how many iterations we require to sort this array? हा array sort करण्यासाठी किती iterations लागतील? लक्षात येते का? Is it necessary to repeat the things? Or is it too easy? Hello, समजलं का नाही? So I'm not getting the response from you, sir.
Sir, n-1.
n-1 iterations you require. Very good. Then why you're not giving the answers? N is the number of elements, right? Now suppose here how many elements are 5 elements. So how many iterations you require to sort out the element? 4. 4 is right.
Yes, sir. Yes, sir.
Okay. Now this is the bubble sort, right? So here the program already you have implemented, right? Same program already you have implemented. Now here you can see. So this is the input array 1, 8, 4, 6. So how many iterations are required? So this is the first Am I audible?
Yes, sir.
Yes, sir.
Here you can see the output, right? So iteration. So here first two element is compared. Now is it visible properly? Now this output, all of you, so this is the list, array list. Is it visible to all, array list?
Yes, sir.
Yeah. So what we have done, so first we have compared 1 and 8. Swapping is not required. After that 8 and 4, right? Swapping is required. 4 is swapped at this side. After that next 8, 6. After that 8, 0, 8, 3. So everywhere we need to do the swapping. So this is called as a, after that 8, 5, 8, 2, 8, 7, 8, 9. So 8, 9, last swapping we have not done. But before that, all the elements we have swapped. So this is called as a one iteration. This is called as a one iteration, right? And here, so at the end, we'll get a one element, which is highest element, right? After that, in the second iteration, so we'll get 8, 9. Here, already they are in a sorted order, so that's why we got an extra element 6, 7, 8, 9, right? So in this way, so here we have performed 5 iterations, right? But how many elements are there here? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n minus 1. So maximum you need to perform the 9 iterations, right? And minimum maybe within 1 iteration or within 2, 3 iterations. So you will get the array in a sorted order, right? So that is depending on the list. So if the list is already in a sorted order, so few elements are only not in a sorted order. So at that time you require the less iterations, right? So if the list is in a in a ordered manner, already in ordered manner, so few elements. So these kind of list is called as adaptive sorting list, right? I hope so all of you have understood the bubble sort. Bubble sort लक्षात आलं सर्वांच्या? Is there any difficulty for the bubble sort? Yes or no?
No, sir.
Not understood or yeah, understood? So if you have understood, so you can write in the chat box yes. If you are not understood, so you can unmute yourself and ask the question. All of you write in the chat box. Okay, good. So all of you understood the bubble sort, right? Now next is the insertion sort. So this sort is in place comparison based sorting algorithm, right? Now here we are maintaining the sublist. Sublist is maintained, so which is always sorted, right? Now, for example, the lower part of an array is maintained to be sorted, and the element which is to be inserted, So in this sorted sublist, has to find its appropriate place, and then it has to be inserted there. So that's why here insertion sort the name is given. Now the array is searched sequentially, and unsorted items are moved and inserted into the sorted sublist in the same array, right? So here in the insertion sort, we are using one sub array, and this algorithm is not suitable for large data set, as its average and worst case complexities are very high, right? So n square. So previous algorithm we have seen. So complexity, what is the complexity of previous algorithm? Worst case complexity. Big O of what?
2 raised to 2.
2 raised to 2, right? 2 raised to. What is the complexity of bubble sort?
Big O of n square.
Bubble sorting तीच आहे. What is the complexity? I'm not sure.
Sir, O square.
Yeah, it is. For the insertion also it is same. So this is the worst case complexity, right? Now in the insertion, so what we are doing? So we'll see. Same example we'll consider here. So 1433. Now we take an unsorted array for our examples. So insertion sort. So compare the first two elements like a bubble sort, right? It finds that the both 14 and 33 are already in an ascending order. So for now, so 14 is sorted in a sublist. Now, if they are in a sorted order, so what you are doing? So first element or smallest element you are keeping in a which list? Sublist. So here we are maintaining the sublist at the left side, and at the right side, so we are considering our unsorted array, right? Now after that, so you are comparing the next two elements, 33 and 27. Now insertion sort moves ahead and compare the 33 with 27. But here again, 33 is not at correct position. So what you need to do here? काय करावं लागेल? Swapping. So can we do swapping here? Swapping करू शकतो
Yes,
का?
sir.
Yes. So it swaps the 33 with 27. Now it also check with all the elements of a sorted sublist. Now after swapping, so this 27 is added in this sublist. Now how many elements present in the sublist? Sublist we will maintain by
2 elements.
Previously it is 1. Now after adding of this 27, how many elements are there? 2 elements, right? Now if 2 elements are present in the sublist, now again we are checking the sublist. So when you are inserting the element in a sublist, so we are inserting that element at proper place only, right? So 27 again we are comparing in a sublist. Now here also we are comparing. Now again, when you are inserting the sorted element in a sublist, so at that time again you are comparing with the existing elements, right? So if it is less than the existing element, so you are inserting before that, sorry, depending on the available element, right, size. So if 14 is there, so now 27 is greater than 14, so we are inserting the 27 after 14. Now in case, suppose here next is 10 we are inserting, so 10 we are inserting before the 14. Why? Because the 10 is smaller than the 14, right? So likewise, so we are maintaining the sublist in an insertion sort, right? So here, so first we'll swap this 33 and 27, and it also check with all the elements of the sorted sublist. So here we see that the sorted sublist has only one element, 14, now 27. Now 27 is greater than 14, So hence the sorted sublist remains sorted after swap. So 14 and 27. So this is the sublist. Now here is denoted by using the green color. Now next two elements. So which next two element you need to compare? Next दोन element कोणते compare करणार आहे? Which element you are comparing next?
33 and 10.
33 and 10 you are comparing, right? Now, is it necessary to apply the swapping? Swapping करायची गरज आहे का इथं?
Yes, sir.
Yes. So we are applying the swapping concept here. So 33 is swapped with 10, right? Now 10 after swapping, so we are inserting 10 into the sublist, right? But after inserting the 10 into the sublist, so the sublist is in a sorted order or not?
No, sir.
No. If it is not in a sorted order, so again, so whatever the new element you have inserted in a sublist, so which new element you have inserted in sublist? कोणता नवीन element तुम्ही insert केला आहे?
10.
10. So that 10 you need to compare with the neighboring element. 10 you need to compare with the neighboring element. So first you need to compare with the 27. So who is greater here?
27.
27. Swap to them, right? So immediately you are applying the swapping here. Now again you need to compare the 10 with the left side element, right? So 14 and 10. So here again who is greater?
14.
14.
14.
Now again we find the 14 and 10 is in the unsorted order. We need to apply again swapping, right? So here the 10 is swapped, right? Now the sublist is in a sorted order. Now it is in a sorted order, right? So by the end of third iteration, so we have sorted the sublist of the 4 items. Only 3, no? 3 atoms, right? So here 4, how it is? So here is the, right? Now this process goes until all the unsorted values are covered in the sorted sublist. Now we shall see some, so after that, so what is the next process? What is the next? Next काय असणार आहे आता? Next comparison. 3 elements. 33 will compare with 33, 35, right? So already they are in sorted order. So add 33 in a sublist. So after adding the 33 in a sublist, so already it is at proper place. Sublist is a sorted order. Sublist sorted right ka 33 add केल्यानंतर?
Yes, sir.
Yes. Now compare 35 with 19. So is it necessary to apply swapping?
Yes,
Yes,
sir.
sir.
19 will be added, swap first with the 35, and after that 19 is added in the sublist. Now the sublist, after adding of 19 in a sublist, the sublist is in a sorted order or unsorted order?
Unsorted order.
Unsorted order. So again you need to compare 19 with the left side element. So 33 is compared with 19. So 19 is up here, but after that 19 with 27, 19 with 14, right? So it will remain after 14. 19 will be placed after 14, right? Now after that you are comparing the next two elements. So the same process is repeated till the element is sorted out. So till the last element, right? So this is called as a insertion sort. This is called as a insertion, right? Now what is the difference between the bubble sort and insertion sort? Then what is the difference? काय difference आहे insertion आणि bubble sort मधला? What is the change? Now for both the algorithms you are using the comparison. You are comparing the elements. Then what is the change? What is the difference between the bubble sort and insertion sort. I guess one by one, I'm expecting from your side. First difference. Complexity of the both the algorithms are, what is the complexity of both algorithms? O of n square, right? So this will not become a difference, right? Now, so for the bubble sort, so what you are doing? You are comparing you are maintaining sublist in a bubble sort,
No, sir.
and in insertion sort, you are maintaining sublist also. This is the first difference, right? After that, next. Now, bubble sort performs sorting by checking the neighboring elements and swapping them if they are in a wrong order. While insertion sort performs the sorting by transferring one element to a sub-sorted array at a time. Right. Okay, good. At the time of your POE exam, so definitely such kind of questions will come. So be prepared with the questions. So difference and everything, right? So algorithms and pseudocodes. So I will share with you all, so you can go through the implementation. Now next algorithm is the selection sort. Now selection sort, right? So in the selection sort also, we are using the comparison based methods or approach. So comparison approach or same. So whatever the approach we have used till previous two algorithms. So same approach we are using, comparison based approach, like comparing the two elements, right? Now, but here, so what is the change? So here we have created the two parts. So in the first part, we are storing the sorted elements, and in the second part we are storing the unsorted elements, right? So initially the sorted part is empty and unsorted part is your entire list, right? So how to do or how to process this sorted and unsorted part, or how to check? So that we will see by considering the example. So how the selection sort is work. Now again, here complexities of this algorithm is also same. So big O of n square. N is the number of atoms. Now, so consider this is the array, right? Same array, same examples again we will consider for the selection sort. Now, for the first position in the sorted list, the whole list is scanned sequentially, and the first position where 14 is stored presently. So we search whole the list and find the 10 is the lowest value, right? Now, so we are considering one element out of that list. So first element we have considered, that is the 14. And what we are doing here, so we are comparing 14 with the all the elements from the left to the right. Now this is the selection sort, right? In the selection sort, what you are doing? So you have considered the 14, and after that 14 you are comparing with the 33, 27, and after that 10. Now here 33 is greater than 14 or less than 14?
Greater than 40.
Right. After that 27?
Greater than 40.
Yeah, and 10?
Less
Less.
than 14.
less than 14. Now, if you found the element which is less than the first element, so what you are doing? So we replace the 14 with 10. So after one iteration, so 10, which happens to be minimum value in the list, so appears in the first position of the sorted list, right? So after first iteration, so this 10 will become the first value, right? So first element we are comparing with the next element, right? Now after that next, now for the second position, so 33 is present, right? Now we are considering, we start scanning the rest of the list in a linear manner, right? So 33 will consider. Now 33 will compare with the remaining list. So 33 first will compare with 27. After that 14. Just 1 minute. Now here first we are comparing with what? Whom? 27, right? Just 1 minute. Now, when you are scanning the element, right? So here, so when we are scanning the second element, right? So first element we have scanned, right? That is 10. So 10 we have replaced or placed at the first position. Now for the second position, so we replace 14 with 10 after one iteration, 10. So which happens to be a minimum value in the list, appears in the list of the people. Now for the second position, so 33 is there, right? Now we start scanning the rest of the list in the linear manner, right? Now who is the next smallest element in the list? The next smallest element कौन है हमें? Next smallest element. Hello. So we have identified the first smallest element here, right? And that we have replaced with the first position, right? Now second position already decided by or occupied by the 33, right? Now we need to place the second smallest element. Now first we need to identify the second smallest element in the rest of the list. Now who is the second smallest element here in the list? The second smallest element कौन है?
14.
14, right? Now 14 we have identified. Now where to replace the 14? 14 कुठे replace करावं लागेल?
At second position.
At second position, and whatever the value is present at the second position, that is placed at the position of 14, right? 14 आता इथं आला, 33 इथे. Now next third position. So third position is occupied by 27. Now again we need to find out the next smallest element. Now identify the next smallest, third smallest element. So we'll scan whole
19.
list 19. Now 19 we need to replace with the 27, right? After that, next is the 33. So scan whole list. Who is the smallest?
27.
27.
27. So after that, scan remaining list. Kona is smallest here.
33.
33 is replaced with the 35. Right now, after that, scan the remaining list.
So it is sorted order.
It is already in a sorted. Now let's see. So here, so you will get the list in a sorted. So these kind of sorting is called as a selection sort. Let's open kind of open selection sort. So what is the procedure of a selection sort? So first you need to first element you need to replace with the or first index or zeroth index element you need to replace with the smallest element. So for that purpose you need to scan the entire list. You need to scan the entire list and you need to identify the smallest element. Now here the algorithm steps are given. So set the mean to the location 0, right? And search the minimum element in the list and swap with the value at the location mean and increment mean 2 point to the next element and repeat until the list is sorted. So this is the algorithm. Now all of you understood the selection sort concept of theoretical concept of selection sort. Yes or no?
Yes, sir.
Okay. Now next is the very important sorting algorithm, that is the merge sort. Now for the merge sort, so we are using the technique. Now for the previous 3 sort, so what type of technique we have used? So we have discussed the bubble sort, after that linear sort, after that selection sort. So for these 3 algorithms, so we are using the comparison technique, right? Comparison based algorithms are there. Now for the merge sort, so we are using the divide and conquer technique. Here we are dividing the list into 2 equal parts, and after that, so we are checking or we are dividing the list into 2 equal parts. So one is at left side, after that another one is the right side. Now again we are dividing this sub list into equal 2 parts. Like this we are dividing whole list up to till, so we get a smallest element. And after that again we are combining them by considering their sequence, right? So this is the merge sort, right? Now merge sort first divide the array into equal parts and then combine them in a sorted manners. So these are the concept or these are the approach we are using for the merge sort, right? So divide and conquer. Now complexity of the divide and conquer merge sort is the big O of n log n, right? So that we will see. Now how merge sort works. So by considering the example, now same list we will consider. Now we know the merge sort first divide the whole array. Now here this whole array is now how many elements are there in this array? How many element is there in this array? 8 elements. Now first you can divide this array into 2 parts, right? So first in the first part 4 element, in the second part 4 element. After that, now again you can subdivide it into the 2 parts, right? So first 2 element, next 2 element. So here two element, two element. Is it visible to all? So these pictures.
Yes, sir.
Yes, sir.
Now, is it easy for you to understand? Is it the way? So directly I'm discussing by using some pictorial representation so that you are able to understand fast. Is it okay for you all? Or I need to use some words and writing the things? Is it okay? हे सोपं जात आहे ना असं पिक्चोरियल डायग्राम असल्यानंतर येस और नो का समजत नाही हॅलो हॅलो अरे काय तर सांगा येस
Okay, sir. Okay.
Okay, sir. It's okay.
Yes, sir.
okay good now again you need to subdivide so further divide this array and we achieve the atomic value which can no more be divided. So here we have find the single values, right? So 14, 33, 27, 10, 35, 19, 40, right? Now we combine them in exactly the same manner as they were broken down, right? So, but please note here the color code you can consider here. Now, initially we have broke down these two values, right? Last broke down, right? So these two values, after that these two, right? Now, in the same manner, we'll start the combining also, right? Now we first compare the elements for each list and then combine them into the another list, right? So first list is 14, second list is 33. So compare these two lists, 14 and 33. So it is in the sorted order. The sorted order.
Yes, sir.
Yes. So combine them here, 14 and 33. Now compare these two, 27 and 10. So they are in a sorted order or unsorted order.
Unsorted order.
So convert them into the sorted order and combine them. So 10 and 27. Now after that, 35 and 19. They are in a sorted or unsorted,
Unsorted, sir.
right? So 19 is considered at first and up to the 30. Now check 42 and 44.
Sorted, sir.
Already they are in sorted. So use the same and merge them, right? So here, in next iteration of the combining phase, so we compare the list of two data values and merge them into a list of data values. So in a sorted order, right? Now combine these two lists, right? So these two lists are in a sorted order. If we combine them,
No, sir.
no. So we need to consider them, or we need to store them at their sorted order or at their proper place. So here, so 10 I will place first. So after that, second highest element, 14, 27, 32, right? In the same fashion, so we'll combine these two also, 19, 35, 42, and 44. Now after that, so final merging, the list should look like this. So 10, 14, 19, 27, 33, 35, 42, and 40. So these kind of sorting is called as a merge sort. So what type of approach here we have used? What type of approach? Comparison approach? Yes, required. But before that, what is the main approach we have used here for the sorting purpose? Divide and conquer approach, or you can say divide and combine also. Now the steps of the algorithm. So if it is only one element in the list, so it is already in sorted order. If not, so divide the list recursively into two equal parts until it can no more be divided, right? And step 3 is merge the smaller list into new list in the sorted order. Now this pseudocode I will share with you all. Now, any doubt up to this?
No, sir.
Just 1 minute. Let me check. Shall I complete the next one or? Is it sufficient? Hello?